Hi everyone, in today's lesson we're going to talk about how to write the equation of a polynomial function that is graphed, just like this one here. Now I know this graph is a little off on the roots, so just to make it easier for us, I'd like to make the roots be -3, 1, and 7. Okay, so first let's talk about what the degree of this function is. And the way that we analyze the degree is if we look at the end behavior. So if we look at the ends, it's going up and down in those two spots. So our end behavior is like this and like that. And that models a negative x to the third function. So we know this degree must be odd of some sort. And we know the leading coefficient must be negative. Okay, now we have the roots. Well, we just established the roots are -3, 1, and 7. So -3, 1, and 7. Okay, now if we could put all this information into factored form, that would be great. So factored form, remember from yesterday's video, is f of x equals some k value, which we don't know, times all of the roots. So if it's a root as -3, then in the equation it's going to be x plus 3. And if there's a root of x equals 1, then when I put it into the equation, it's the opposite, x minus 1. And then the same with the 7, so this root is +7, so the equation is x minus 7. So this is your factored form of the equation. Now we need this k value because isn't there an infinite number of graphs that could go through this? Like say I decided to go up a little bit wider and then down and then up through it, but then down this way and then out like this. So I can make an infinite number of graphs through these three roots right here. So that's why we need the k value, so that we make sure we know exactly where it lands. Okay, now let's figure out f of 0. And f of 0, if it helps, write f of x underneath it. So basically, when x is 0, we want to know what y is. So this is the same thing as saying the y-intercept. So if we look at our graph, our y-intercept occurs at -6. So 0, -6 is the y-intercept. So now we're going to use this information to find the k value. So let's rewrite our equation. F of x equals k, x plus 3, x minus 1, and x minus 7. So if we know a y value and an x value, we can find k. So right here I have an x value and a y value. So I'm going to plug in y is -6. I'm going to leave k alone because that's what I want to find. And I'm going to plug in x is 0. So 0 plus 3, -1, -7, and plug in 0 for all of the x's. Okay, so now let's do some math. So we keep the -6 equals k, 0 plus 3 is 3, 0 minus 1 is -1, and 0 minus 7 is -7. So if we do the math and multiply 3 times -1, we'll get -3. -3 times -7 is +21. So this is 21k equals -6. Divide both sides by 21. So our k value is a -6/21, which I think you can simplify if you divide the top and bottom by 3. So -2/7. So if we put this into our equation for our factored form, we'll write it, I'll just write it down here, f of x equals the k value, which is -2/7, x plus 3, x minus 1, and x minus 7. So let's just check that this equation now matches this equation. I have 3, -1, and -7 as my factors, so my roots would have to be the opposite. +3, which is, -3, which is here, positive 1, which is there, and positive 7, which is here. And my degree is 1, 2, 3. I have a leading coefficient that's negative, so everything checks out. Now, another thing that you could do is just plug this into the calculator to see if this matches this, and it will. Okay, why don't you see if you could try the second example all by yourselves, and then hit resume when you're finished. Okay, your degree should have been even because it models, the end behavior models a positive x squared graph. These pieces model the end behavior as even. My leading coefficient is positive because, again, it looks like a positive x squared graph. Your roots are at -2, 0, and positive 2. These values here, -2, 0, and 2. So if I wanted to write this in a factored form, we're going to start with f of x. So I'm just going to bring this down a little. We're going to start with f of x equals some k value, which we don't know, times. Now, I know I have a root at 0, so it's always nice to put that factored form out here as just x. Because, you'd set a t-chart, x equals 0, and then you can put the -2 and positive 2. So +2 and -2. Okay, if I look at my factored form right now, if I put my degrees back, I have 1, 2, 3. So right now, my power is 3, but we said this degree had to be even. So is there anything that you see in this graph that really should have changed what you put as your exponents there? Well, you see over here how I have a bouncing root at -2. All bouncing roots have to have even powers. So you can choose whichever one that you want as far as putting a power, a 2, a 4, a 6, it doesn't matter. But the root is at -2, so it's the positive 2 one that we would have to put an even degree with. So you could put a 2, I'll put a 4, it doesn't matter. But now when I count my powers, I have a 1, 2, and then a 4, which makes a 6. So I do have an even power. Okay, now I have a y-intercept, f of 0. Where does this thing cross the y-axis? Crosses it at 0, 0, so that's my point. Now, if you plugged in 0, 0 into this equation, real quick, look, just see what happens. 0 equals, you keep k, then you have times 0, 0 plus 2, 0 minus 2, or to the 4th. So 0 equals k times 0 times 2 to the 4th times -2. Now, it doesn't even matter what all this stuff multiplies to, because when I'm doing k times 0 times this, 0 times anything just cancels each other out. So all we're doing is actually proving this equation is 0 equals 0. So the only value that really could work for k here, I mean, it could be an infinite number of values, so you really don't even have to worry about this too much. We're just going to assume that k equals 1 when this happens. Okay? So, let's write this in factored form. So we have f of x equals, we're leaving k as 1, so x plus 2 to the 4th, and x minus 2. Alright, that would be a possible equation. Remember, there's an infinite number of possible equations that you could have, but this is one possibility here. Alright, write down any questions that you have, and we'll go over them tomorrow in class.